What we want to do on this one is we want to make a quick sketch. And it's also asking us to find the intercepts, and so we're going to do that. Once we have the sketch on there, it'll be easier to find the intercepts. So first thing I'll do is I need to figure out which one of those original functions I'm going to use, my library functions. And so it's an absolute value, so I want to use the one for absolute value of x. So that one is the V-shaped graph that I showed before, and it goes through 1, 1, 2, 2, 3, 3, and so forth. We're going to use this as our base graph. It always starts at 0, 0, and with these transformations are going to move it to its new location. So to do the graph, first we start at 0, 0, and we're going to take a look at these two transformations that we have going on here. First, you've got a +1 on the inside, which means we're moving opposite direction of what we have on the inside. So instead of moving it to the right, we're actually moving it to the left. So we're moving opposite direction of positive would be the negative direction. So we're going to go one place over to the left. But then also the +1 here means that we're going to go up 1. So this is going to be your new starting point. It did start at 0, 0, but we're moving it 1 to the left and up 1, and that takes care of those two transformations. Now we also notice that there's a negative on the outside. So we mentioned before that the negative is going to flip the graph over the horizontal axis. So instead of the graph opening up like this, the graph is actually going to look like the dotted lines here. So opening up, it's going to open down. So because it opens down, it'll be opening down from that starting point right there. This is your vertex. Now we know that it goes up 1 over 1. So instead what we're going to do is we're going to go down 1 and 1 to the right, and down 1 and 1 to the left. So we're going to go down 1, 1 to the right, down 1, 1 to the left, and it's going to look like that. So it opens down. So then it's going to go like this and like that, and you can continue it down 1 over 1, down 1 over 1, but that's a good enough sketch here because all we want to do is basically find the intercepts from that sketch. So first we're going to do the x-intercepts. It's where it crosses the x-axis. It's going to cross at -2 and 0. The y-intercept, that's going to cross also at 0 right there. So there's your two intercepts, and this will be your sketch. So again, the whole idea for doing these transformations is just to allow you to make quick sketches so you don't have to make a table. Okay, for this one we notice that we have a square root there. So y equals square root of x is the base graph that we want to use. Let's draw the graph of that one. This one is the one that looks like that. Starting from 0, 0, it goes through 1, 1, and it goes through 4, 2. So we want to know what the base graph looks like first. Normally it starts at 0, 0, but we need to move it. Now, normally the transformations start with x plus or x minus something. What we notice this time is that the order is switched. So it's very important before you start doing the graph, we need to put this in the proper form so we know what the correct transformations are. We're going to switch this. We get -x plus 4, and you have a 2 on the outside. So now at least we have the x that comes first. But we're still not done because all the transformations that we had where we move it left or right starts with x plus or x minus something. In this case there's a minus sign in front of the x, and we don't want to leave that negative in front of the x like that. We want to factor it out so we can get x to be positive. Now of course when you do that, it'll also change the sign of the 4 and it'll make it negative. So I have negative, I have x minus 4 on the inside there, and then I have a plus 2. So what this is going to do is it's going to take the graph that normally starts at 0, 0, it's going to move it 4 places to the right and then up 2 units. Alright, so when we do that, let's draw that one out. We're going to go 4 places to the right, and then we're going to go up 2 units, which means the graph is going to now start right here. So instead of having it go through 0, 0, it's now going to start here at that point. So that takes care of the left and right up and down movements. But now we notice that there's a negative this time on the inside of the function. A negative on the inside, what that does is it takes the graph and it's going to do this. It's going to flip it to where now it's going to open up to the left instead. So I need to recreate that here, but I have to make sure it goes through the correct key points. So here's the original one that corresponds to 0, 0. Now normally what I would do to get this next point is I would go 1 to the right and up 1, but this time I'm going to go 1 to the left and up 1 from the starting point. Okay, so I'm going to go from here, 1 to the left and up 1 means that this key point is now going to be at 3, 3 is where the next one will be at. So again, I went 1 to the left and up 1 because that's what I would do on my model to get the next one here. To get this one, I would go normally 4 to the right and up 2, but instead I'm going to go 4 to the left and up 2 from my starting point. So if I go 4 to the left, that takes me back to the x-axis. If I go up 2, that's that dot right there. So then I can connect the dots right there, and now I have my graph opening up to the left. So again, the reason why it opens to the left, because you got a negative sign on the inside, and again it flips it over the vertical axis. Now we're going to do the intercepts. We got x-intercept. We want to see where it crosses the x-axis. Now, the graph does not cross the x-axis at all, so in this case we're actually going to put none. There is no x-intercept. What about the y-intercept? Where it crosses the y-axis. Crosses the y-axis here at 4. So that would be the one and only y-intercept. So we have our completed graph. We're able to make a quick sketch, and then here's your intercepts.